Welcome back to the fourth week. In this week, the first video is going to be about cost curve, and this is going to be the final video on cost curve. The previous videos are titled cost curve 1 and from cost curve to supply function. So, this video we will conclude our discussion on cost curve. So, in the last video of the last week, we learned how to move from cost curve to supply function, and we will do that quickly here. This is what we had figured out. We have taken two axes. On this x axis we have quantity. Sometimes we also indicate it using y. Let me make it bigger so that it's clearer to you. And then we were able to draw first average variable cost curve. We also understood that average variable cost decreases when marginal cost is below average variable cost, and average variable cost increases when marginal cost is above average variable cost. And we also figured out that at very low level, say that at 0 level, the marginal cost is equal to average variable cost at that level. So, it helps us draw the marginal cost curve. So, it should look like, and this is the marginal cost curve. So, that is what we had figured out. And then we talked about supply function. So, we said that for supply function what we need to give Q as a function of P, and this P is the market price of the item on per unit basis. So, of course, we already know higher the price, higher is the willingness to supply, but using this graph we were able to quantify it clearly. So, first we figured out, because you know, if at this level of price we see the marginal cost curve can give us two different labels. So, which label to take, and we had figured out that this particular label we should be taking and not the this one. So, from here we figured out that marginal upward sloping part of the marginal cost curve is really important. So, where is the upward sloping part? This is the upward sloping part, and so this can give us the supply function. Okay. Then we said that we have to be careful about one more item, and that is firm should check, the firm manager should check whether it is good idea to produce any output, then shutting down the operation having the zero output, and that can be good idea when your marginal cost happens to be lower than average variable cost curve. Here it is not good idea to produce anything. Why it is not a good idea? Because you are not even able to recover your variable cost. When you produce, you incur variable cost, and the price is so low that you are not even able to recover your variable cost from the market. So, you should not produce anything when your price is lower than average variable cost. This is called shutting down the operation. Why would you not care about fixed cost? Because fixed cost is already sunk in the short run. You should not worry about it. So, then what is the conclusion? The conclusion is very simple. You should pay attention to the upward sloping part of the marginal cost curve that lies above average variable cost curve. So, simply speaking, that P is equal to MCQ, because when we are drawing we have P on y axis and Q on x axis. So, even when we say the supply function is Q as a function of P, but when we are drawing P as a function of Q, and this curve is the basis. Marginal cost curve gives us that supply function, with two caveat that we just discussed, that we have to pay attention to the upward sloping part and the part lies above average variable cost curve. that's how we get the supply function. That is what we did during the last video of the last week. Now let us move further. Now we are going to talk about short run versus long run cost, and we alluded to this in the last video also. So little bit is revision, but then we will also learn new things about it. So we have this axis where, let us say, on x axis you have L and y axis you have K, and then you can draw the ISO cost curve. Remember, the ISO cost curve are going to be parallel to one another. This is the way ISO cost line will look like, because how do we get the ISO cost line? We take RK plus WL, where R is price of 1 unit of renting the capital and W is the price of 1 unit of labor in hourly basis, or whichever unit that we are using. So this, if we put it equal to a number, let us say that number is C or C naught, we get an isoquant. By changing this C naught, we can get different isoquant. So isoquant is basically the combination of capital and labor that cost us same in hiring. So let us again take constant return to scale Cobb-Douglas function. Let us say, for example, k to the power half and L to the power half. This gives us the output Q or Y, whichever way you want to. So we can say, let us say, we can say it like this. Let me draw, and this is going to be, let us say, and some, some we are drawing, not all. So this corresponds to Q1, this corresponds to Q2, this corresponds to Q3, and we can say this is the optimal level of labor capital, this is optimal level of labor here, this is optimal level of capital, and this is the optimal level of labor, and this is optimal level of capital. Okay, let's make it bigger so that you are able to understand it well. Of course, we are talking about long run. Why are we talking about long run? Because we are able to vary both capital and labor. In short run, we have discussed that we won't be able to vary capital. Then what would be the situation? Let us say the situation is that capital is at K2 level. This is, let us say this is the way. Now what will happen here? That if this is the case, how much would be the cost to produce Q1 unit of output? If we pay attention to ISO cost, it would cost this much to produce Q1 level of output in the short run. Clearly we see the cost here in the short run is higher. How about when we want to produce Q2 level of output? In this case, it so happens that K2 is optimal level of capital required, and you will select L2 to produce Q2 level. So short run total cost and long run total cost both would be equal. What would be the case here? If we draw the ISO cost line, it will be something like this for Q3. Of course, it's higher than, this is the ISO cost line, this combination K3 and L3 are on this ISO cost line. But if you have fixed capital of K2 and you need to produce Q3, you need to come here, and ISO cost line that you will be using is going to be higher. So what did we figure out? That in case of Q1, short run total cost is going to be more than long run total cost. In case of Q2, short run total cost is going to be equal to long run total cost, and in case of Q3, short run total cost is again going to be higher than long run total cost. It does not matter, we started with K2 level of capital, and therefore, here both short run and long run are giving the same cost. We could have started with K1 level of capital, and in that case SRTC1, that is short run total cost at Q1, is going to be long run total cost at Q1. And similarly, if we had started with K3, the short run total cost at 3 is going to be equal to long run total cost at 3. And at all other level, short run cost is going to be higher than the corresponding long run cost. We can spend 1 minute to understand that why it is happening, that why at K1 they are equal. So, long run total cost, how are we getting? This is not just any cost, this is the optimal level of cost, and this is basically the cost to hire L1 unit of labor, let us say here L1 unit of labor and K1 unit of capital. That is what you have done in the long run. But in the short run, you already have K1 level of capital and you are allowed to hire the optimal amount of labor. So, you will hire L1 and therefore, both would be equal. But when you have K1 amount of capital and you want to produce Q2 amount of output, K1 is not optimal. You could have used more of capital, that would have given you lower price, lower cost. But you are forced, because in the short run you cannot change the capital immediately. So, you are forced to use K1, and therefore, your total cost in the short run case, when you are using K1, here your short run cost in case of 2 is going to be your long run total cost in case of 2. So, this logic is valid everywhere, okay, and that is why you are getting different cost structure. So, what we have figured out, that short run total cost at label, let us say label N, is either equal or greater than corresponding long run total cost. That is what we have learned. Now, if we want to draw it in a graph, that we have on x axis the amount of output, and on the y axis we have total cost in short run as well as in long run. So, if we want to do it for the long run, we have already learned that as we are taking the constant return to scale, it is going to be linear, as we have already learned that average cost, long run average cost is constant in the case of constant return to scale, and long run total cost is linear, because if it is constant then it is going to be linear. So, it is going to look like this. This is the long run total cost. How about short run cost? We figured out that if we use, let us say, the optimal value, then the short run total cost either is going to be equal to long run total cost at corresponding level, or it is going to be higher. So, we can get something like, let us say this, and this is the short run total cost. But of course, short run total cost, here we have used, let us say this is the Q naught. So, for short run total cost Q naught, what we are using? The optimal capital, and that is why the short run and long run total cost are equal. If I want to draw another short run total cost curve, let us say at level of Q1, what it means, that at Q1, let me use a different color. So, black. So, it is going to be something like this, and let me write here short run total cost Q1. Here it is equal, but at other place. But how to figure out the way we have drawn, and we are assuming that Q1 is greater than Q naught. What we are assuming that, let us, if we extend the curve, this is going to be fixed cost and this is going to be fixed cost in the second case. And what we have, two things that we have figured out, that short run total cost in Q1, here the fixed cost is higher than, let us say, fixed cost at Q naught. The other thing that we have figured out, that the marginal cost at Q1 is also greater than marginal cost at Q2. Why? Because we see that average here, that short run total cost at Q1 is climbing at a smaller rate than short run total cost curve at Q1. So, we try to understand these two things in the next slide. So, first let us look at the fixed cost. When we talk about short run total cost at Q1, how are we getting the fixed cost? The fixed cost is coming from capital. So, RK1 is the fixed cost. This, and manager is not allowed to vary. Okay. So, if you look at SRTC Q naught, then RK naught, and as we are assuming that K1 is greater than K naught, of course, RK1 is going to be RK naught. So, higher fixed cost mystery is solved. Total cost in the long run is simply RK naught plus WL naught if the output is Q naught. Okay, let us look at it. So, that part is clear. Now, we have to look at the higher climb rate in one versus the other. So, let us look at from where are we getting the marginal cost in the short run. What is the marginal cost? The cost to produce one more unit. So, capital is already fixed, capital in the short run is fixed. So, the variable part is coming from labor. Okay. How much of labor you need to produce one extra unit? Let us say marginal productivity of labor is MPL. What does it mean? That one labor gives you MPL unit of extra output, but we want just one extra unit of output. So, how many labor would be required? The labor required would be 1 by MPL. And so, how much will it cost? The cost, marginal cost, because a labor cost W, so marginal cost is going to be W by MPL. This is the marginal cost. This is what we are getting as marginal cost, that is the relation in the short run. Now, if let us say the way in the previous to previous graph we have used K3 is greater than K2 is greater than K1, or in the last graph we have used K1 is greater than K naught. If we have higher amount of capital, if capital complements labor, it means in presence of labor, in presence of capital, labor has higher productivity. We can say if capital is fixed at K1, MPL is going to be higher than MPL 0. It means capital complements labor. In that case, of course, higher the capital, higher would be the denominator, and lower would be the slope, because slope is coming from the marginal cost. So, this is exactly what we do. We say labor and capital, they complement one another, and MC is equal to W by MPL, as in this case we have lower capital and therefore lower MPL and therefore higher marginal cost, and that is how we get the slope. So, now the graph should be very clear to you. So, now we have clarity about total cost in short run as well as in the long run. Let us look at the average cost as well as marginal cost in short run as well as in long run. This we have already done, marginal productivity and marginal cost we have already figured out. So, let us look at average cost. So, if we have the constant return to scale, then long run average cost curve will look like simply a straight line that we have figured out. And now the short run average cost would depend on the amount of capital that a firm is using. Of course, this is short run average cost for the first case when capital is lowest, short run average cost for the capital is middle level, short run average cost for capital at higher level. That is the way it would go, and we will see long run average cost is going to be enveloping these short run average cost from below. That is what we have figured out. Let us look at the graph once again. At this point for Q naught, short run average cost and long run average cost both would be equal. At all other places, if capital is optimal for Q naught, then at all other places short run average cost, let us say like for example this level, the average short run average cost is going to be higher, because this angle, this is the total cost. So, this angle will give us average cost for long run, and this angle will give us the average cost for short run. So, everywhere it is going to be higher. The other case we can consider when long run average cost itself is first falling and then it is increasing. So, what we mean that here in this zone we have economies of scale, and in this zone we have diseconomies of scale. We have discussed about them. Here there is Q that is increasing, and then it is possible that we will have short run average cost curve like this, and then this is the way we will have short run average cost curve. This is in the case 1, this is case 2, and this is case 3. Again, these 3 are representative. The way I am drawing that only 3 levels of capitals are possible. It's in reality it's possible that 5 levels of capital are possible, and also it's possible in reality that capital can also continuously vary. So, from here of course we already had logic that how would that marginal cost curve look like. Let us say we are talking about the case 1 only. In that case, the marginal cost curve will pass through the bottom of short run average cost curve that we have drawn. That is the way we had obtained the supply function. And at this point, let us say at this point, the short run, at this point, the short run marginal cost curve, marginal cost is going to be equal to, let us say here, and this is the optimal, let us say Q1. But Q1 dash, the marginal cost for both entity would be equal, and this is the way it looks like. So, if we do it for the long run, the marginal cost curve would be something like, something like this. Let us say that marginal cost in this particular case is going like this. So, that is the way marginal cost curve would look like. So, one can say that how would long run look like if there are only three labels, for example, only three labels of capital possible. Let us say short run average cost curve is so this black is not possible because it assumes that in long run we can vary capital continuously. So it's very clear that it will look like this. This is the way it would look like. Okay, so I hope this concept about short run and long run are clear to you. If there are doubts, we can discuss it during live session. This is very important for you understand. I am willing to clarify these things once again if required, but I would say it's very important that you understand all these things best. This is it for the cost curve. Thank you.